In this video, we'll be looking at solving equations. Now, there are a variety of equations, and if I try to solve all of them in one video, then the video will be extremely long. So this video will be in two parts, and you are now looking at part one. So what is an equation? An equation is an equation in X because there can be more than one variables or different variables in an equation. So we look at an equation in X, and it's an equation in X is a statement that two algebraic expressions are equal. Okay, so let's just write that down. An equation in X. Okay, so what we mean here is that the variable in the equation is X, is a statement. Yeah, is a statement that two algebraic expressions are equal. And if we look at an example of that, we have, let's say, example here, x plus 5 is equal to 7. So in this example, we have this here is an expression, this here is another expression, and obviously we know that's the equal sign. So on the left side, we have an expression. On the right side of the equal sign, we also have an expression. Okay. So here's an example of an equation in X, meaning the variable is X. Okay, the variable is X. So if we look at another example, okay, we have the expression root of 2x, and that's equal to 4. So here is the expression on the left of the equal sign. Here is the expression on the right side of the equal sign, and here is my equal sign. So this is the equal sign. We have something on the right, which is the expression. We have something on the left, which is the expression. Okay. If we look at another equation, we have 1 over x plus 2. That is equal to 3x over 5. So here we have the expression on the left of the equal sign. Here is the equal sign, and here is the expression on the right. So we have our equal sign in the middle. Here's our expression on the right. Here's our expression on the left. Okay. So these are just different types of equations, but I just wanted to point out what an equation is. Equation must contain an equal sign, okay? And generally there's an expression on the right and expression on the left. Now, keep in mind that we can have an example where we have the expression on either side of the equal sign can be 0. Okay, so in this example here, all of this here, okay, make me a little bit neat. Everything here is my expression. Here is my equal sign, and here is an expression. So this here is my equal sign. This is an expression. Yeah, and here is an expression. It doesn't physically have to be equal to a number, but it has to be equal to something. And 0 is also an expression. Yeah. So keep in mind that that's quite possible when it's equal to 0. And you will see later on, specifically quadratics in order to solve them, generally or should be equal to 0. So our goal is to solve these equations. So what do we mean to solve? Well, to solve an equation in X means to find the value or values for X for which the equation is true, meaning the left side is equal to the right side if you plug in back your answer. So to solve an equation in X, okay, once again, the variable we're talking about is X, means to find the value or values, okay, for X, for which the equation is true. Okay. Now I can give you a scenario where you can physically just look at it and you will be able to guess the value of X. Now these value or values, okay, you found are the solution. Okay. The values that you find are the solutions to the equation. An example of this, X plus 5 is equal to 7. Okay. So what should X be when you add it to 5? You get 7. Okay. So we know that X is equal to 2. Okay, is the solution. We can see this because if we take 2 and we add 5 to that, and then we combine these two, we get 7 is equal to 7. And 7 equals to 7 is a true statement. That's our goal. Our goal here, okay, our goal is that when we find that value or values, okay, because we can have more than one answer, as you will see later on, for different types of equations, that is, when you replace X with the value that you found, the left side must be equal to the right side. And that's very important because that's really our checking process. Yeah. So as you solve equations also, you will notice that solutions, yeah, can be either rational or irrational. So remember what a rational number is and what an irrational number is, okay? So just to go over, rational is any number that could be written as a fraction p over q or a over b, and irrational numbers are numbers that decimal does not repeat and are continuous, right? So keep in mind that those exist. And also you will have solutions can be either real or imaginary, okay? So in addition, we're gonna have real or and I shouldn't say real slash imaginary. So those are two things we'll see as we solve equations. Now, an equation that is true for all real number is called an identity. Okay, an equation that is true for all real numbers is an identity. Okay, they're called identity. And an example of such equation is if we have x squared minus 9, and we say that is equal to x plus 3 times x minus 3. No matter what value you choose for x, the left side will be equal to the right side. Okay? So if you pick, let's say, any number, okay? So notice here, okay, any value of x will make this true. Okay? And we can say, let's try x equals 1. Okay? So if we try x equals 1, we have 1 squared, okay, minus 9 is equal to 1 plus 3, and then we have 1 minus 3. So 1 squared is 1 minus 9, and that is equal to 3 plus 1 is 4, and 1 minus 3 is negative 2. And then 1 minus 9 is minus 8, and 4 times negative 2 is minus 8. Okay? And this is just one example. We tried x equal 2. Well, what happened? Let's try a different x. Let's try, okay, x equal minus 3. So if we do this now, we have minus 3 squared minus 9, and that is equal to minus 3, okay, plus 3 times minus 3 minus 3. So I'm plugging in all the blue numbers as negative 3. Now, if I simplify this, this becomes 9 minus 9 equal to minus 3 plus 3 is 0, and minus 3 becomes minus 6. And then we have 9 minus 9 is 0, and 0 times any number is 0. So this, as you can see, also checks, right? So this is a true statement, this is a true statement. And we can continue doing this. We can continue doing this forever. We can do this for a very long time. Yeah, very long time. So when this happens, it's called an identity. These are identities, okay? So this here is what an identity is. Another example of an identity, okay, identity would be x over 3x squared equals 1 over 3x. This here is also an identity. If you pick any value or values, different value of x, you will see that the left side is equal to the right side. So this is very similar to this one here. Okay? Very similar. Same scenario will happen. So as you solve, you will see this. Okay, this is something that you will encounter. So how about a conditional equation? Now, conditional equation is what you have been accustomed to seeing on most occasions. This is the case where we obtain specific value or values when we solve. So when we obtain a specific value when or while solving, okay, specific value. An example of this will be x plus 5 equals 7, okay? In this case, only when x is equal to 2, this x is equal to 2, x is equal to 2, this is true. No other value will make this true. Okay? Another example is if I have x squared plus 7x plus 12 equals 0, okay? And we can say only when x is equal to minus 3 or x is equal to minus 4, this, okay, is true. These are the only two times this is true. Okay? Only two times. So you may want to look at this and see when it's conditional, and you're accustomed to this because you generally solve when you have an answer. Another case we have is what is called a contradiction. Okay, a contradiction. And a contradiction, okay, is an equation that is false, for every real number in the domain. What it means here is that no matter what you try, okay, no matter what you try, it will not work. For example, 2x minus 4 is equal to 2x plus 1. This is a contradiction, okay? This is a contradiction. Okay? And you can see this, if you try to solve. If we have 2x minus 4 is equal to 2x plus 1. So I generally just move my x's first. So if I minus 2x here, then I have the minus 2x there. And if I do this, you will notice that the plus 2x and the minus 2x cancel. And that leaves me with minus 4 is equal to the plus 2x and the minus 2x also cancel, positive 1. And there is no way, okay, this is true. It's impossible. And when this happens, we say this is a contradiction, okay? This is a contradiction. It's not possible. So we see now that we can have three different possible answers. we can have a contradiction, okay? We can have over here a conditional equation, or we can have over here an identity. These are the three possible things we'll see. Now, we can start our solving process. So the first types of equation I will look at is linear. Linear. Well, let's look at linear and rational. Linear and rational at the same time. Yeah, linear and rational equations. So notice or remember that a linear equation can be written in the form ax plus b equals 0. And recall, right? Recall here, a is not equal to 0. A is not equal to 0. If I ask you to solve this, okay, you will see we have ax plus b equals 0, solve for x. And remember, solve for x just means leave x by itself, right? So the first thing we'll do is minus b on both sides, and that leaves ax is equal to minus b, okay? Ax is equal to minus b, and then we divide both sides by a, and we're left with now, this becomes 1, x is equal to minus b over a. So we do have an answer, okay? We did get an answer. Whatever b is and a is, it's an answer. And that's the idea that we'll use when we solve equation. We want to isolate that value, okay? Isolate it, get x by itself. So, solving equations now. Solving equations. We'll start off with a simple case, okay, of a linear equation. So solve 3x minus 6 equals 0. And when we say solve, we mean for x, okay? We're going to solve for x. So we have 3x minus 6 equals 0. What I'm going to do is add 6 to both sides. And if I do this, we have left 3x, the minus 6 and the plus 6, if you combine them, become 0. And then to get x by itself, what I will do is divide both sides by 3. And by doing this, 3 divided by 3 is 1, so x is equal to 2. So observe, right, the original equation, okay, was 3x minus 6 equals 0. And if we replace x with 2, we get 6 minus 6, which is 0. So you always want to do, a check. Check your result to see. So note, okay, note, please check your answer, okay, confirm to confirm it is a true statement. Okay, so I'm going to leave the checking part out for you to do. All you're doing is replacing x with 2. Okay, so that's the idea of checking. If we look at another example, solve. So example, solve. We have 5x plus 4 is equal to 3x minus 8. So I wanted to point out something to you, that the exponent here, the exponent of these x's is 1, right? There is an invisible 1 there. And you will see as you solve equation that the exponent has something to do with the number of solutions you get. Okay. So let's solve this. We have 5x plus 4 is equal to 3x minus 8. I always like to start off with moving the smaller x values first. So I'm going to minus 3x on both sides. And if I do this, we have 5x minus 3x becomes 2x, okay, plus 4 equals the plus 3x and the minus 3x will go to 0, and that leaves me with minus 8 on the right side. So now we have 2x plus 4 is equal to minus 8. The next thing I'm going to do is to minus 4 on both sides, because I do want to leave x by itself. And that will leave me with 2x, the plus 4 and the minus 4 goes to 0, and here I have minus 12. And then, if I want to leave x by itself, I will now divide both sides by 2, and we have 2 divided by 2 is 1, so we have x is equal to minus 6. And you should always perform a check. Remember to check your answer. Now, when I started this problem, I said pay attention to the exponent of the x. The exponent of the x is 1, and notice you have one answer, okay? Notice you have one answer. That does not mean you're going to always get one answer, because remember, no answer is also a possibility, right? So if the exponent is 2, it doesn't mean you're going to have to. It means you will have at most 2 answers. When the exponent is a 1, you will have at most 1 answer, meaning you could have 0 answer or 1 answer, okay? Yeah. So let's look at another example here again. Example, let's solve. And in this case, we have x over 3 plus 3x over 4 is equal to 2. Yeah. So if we're solving x over 3 plus 3x over 4, and that I write it as a fraction also, 2 over 1. So the lowest common denominator is going to be 12. Okay. It's going to be 12. And remember, I said now we multiply only the top. Now multiply only the numerator of each term by 12. Okay. So if we do this, we have 12 times x over 3 plus 12 times 3x over 4 equal 12 times 2 over 1. You will notice as you do this, you're going to have some simplification. 3 1s, 3 4. So you're left with 4 times x, okay? And that will leave you with 4x. Plus, you will notice once again, the 12 and the 4 can be simplified. So 3 times 3x, that becomes 9x. Okay? And you will notice also, once again, the 12 and the 1, there is nothing really to cancel because this is already a 1. So you get 12 times 2, and that is equal to 24. And notice now, there are no fractions. And that was the idea of just multiplying it by the lowest common denominator, so you can get rid of your fractions. That was your whole idea. Okay. So now what we do, we combine like terms. So if we combine the like terms, we have 9 plus 4 is 13x is equal to 24. And to get x by itself, we will divide both sides by 13. And that will leave me with x is equal to 24 over 13. And you want to see, can you simplify it? Now, we don't care to write our answer as a mixed number, so the answer is no, we cannot simplify here. So we leave our answer as 24 over 13, okay? We leave our answer as 24 over 13. So you should ask, or whoever is teaching you math, should you simplify your answer as a mixed number, okay? For this lesson, I don't really care about the simplification, but this is an improper fraction, so please note that. So we can have equations that when we solve, the answer cannot be used, right? We can't use them. So we will notice that there are cases, okay, when we solve equations, okay, the answer cannot be used, cannot be used. And in such case, we say these, or the answer is called extraneous. Extraneous solutions. Extraneous solutions. So there are cases where we're going to solve an equation, we'll get an answer, but when we try to check the answer, and this is very important as to why you check. When you check your answer, you will notice that the answer that you obtain cannot work. Let's look at a scenario. Example, solve. And if I give you the equation, okay, 1 over x minus 2 is equal to 3 over x plus 2 minus 6 over x squared minus 4. So to solve, this is called a rational equation because it has fractions, ratio of two things. So the first thing we want to do, okay, the first thing we want to do is to factor each denominator if possible, okay? We want to factor each denominator if possible, okay? So factor each denominator if possible. So I said if possible, okay? I said if possible because if you notice in your first fraction, there is nothing to factor in x minus 2. In the second fraction, there is nothing to factor, but in that third fraction, there's difference of squares. So when you factor that, you get x minus 2 times x plus 2, okay? So now we can clearly see the lowest common denominator. The LCD is x minus 2. We start off with the first. Then we move down the list. Here we have x plus 2. We don't write repeated. Here we have x minus 2, but we already have x minus 2 there. And here we have x plus 2, but we already have x plus 2 there. So we don't write them twice. So the lowest common denominator is x minus 2 times x plus 2. Okay? And what we will do now is multiply, same as we did before, multiply each term by the LCD. So what do we have? We have x minus 2 times x plus 2, and we're going to multiply that by our first term, which is 1 over x minus 2. Okay, 1 over x minus 2. And that is equal to, we multiply that, which is 3 over x plus 2. We're going to multiply that by our common denominator, which happens to be x minus 2 times x plus 2. Minus, okay, minus 6 over x minus 2 times x plus 2. But don't forget, we also have to multiply that by x minus 2 times x plus 2. Okay. Now, as you multiply this, you will observe that the x minus 2 cancels with the x minus 2. So you're left with x plus 2 times 1. Okay. We're left with 1 times x plus 2. And that is equal to, notice in this scenario, the x plus 2 will cancel with the x plus 2. So I'm left with 3 times x minus 2. So 3 times x minus 2. And then in the last term, we have the x minus 2 cancel the x minus 2, the x plus 2 cancel the x plus 2. So all we're left with is minus 6. Okay. If we now distribute, okay, if we now distribute, we will distribute. So this leaves me with x plus 2 is equal to, multiply everything by 3, 3x minus 6 minus 6. Notice we have here like terms. Yeah. So if we have like terms there and we combine them, we have x plus 2 is equal to 3x minus 12. And now we start moving things around. Okay. I always like to move the smaller x, so I'm going to minus x on both sides. And if I do this, I have the plus x and the minus x cancel, so I have 2 is equal to 2x minus 12. Okay, and then I can add 12 to both sides. And 12 plus 2 becomes 14. So we have 14 is equal to 2x. The minus 12 and the plus 12 cancels. And to get x by itself, we divide both sides by 2. Okay. And if I do that, I have 7 is equal to x. 7 is equal to x. Now, check your answers. Check your answers. Okay, or answer. Check your answer. Now, what is important is that the original equation you have, right? Your original equation was or is 1 over x minus 2 equal 3 over x plus 2 minus 6 over x squared minus 4. If you replace 7 and put it in here, does any of the denominator become 0? If it does become 0, then this is an extraneous solution. If it does become 0, this is an extraneous solution. Very important. So what I'm going to do now, okay, I'm going to change that problem we just did. And let's call that another example. Okay. So continue here. I want to say, make sure the denominator does not become 0 when you check. Okay. If it does, we cannot use the answer. We cannot use the answer. This means we will have no solution if you get 0 in any denominator. Okay, so you want to make sure you check it. So let's look at the example where now you will see that I will get a 0, right? Example, solve. So very similar. We have 1 over x minus 2 equals 3 over x plus 2 minus 6x now over x squared minus 4. So the same thing we'll do. Factor, right? We want to factor out each denominator. Factor the denominators. Okay. And if I do this, I will have 1 over x minus 2 equals 3 over x plus 2 minus 6x over x minus 2 times x plus 2. So we see that the lowest common denominator will be x minus 2 times x plus 2. That's my lowest common denominator. I multiply each term by x minus 2 times x plus 2. So I'm going to multiply that by the first term, which is 1 over x minus 2, equals, the next term was 3 over x plus 2, and I'm going to multiply that by x minus 2 times x plus 2. Then I subtract, oops, we subtract 6 over x minus 2 times x plus 2, everything, and I'm going to multiply that also by x minus 2 times x plus 2. So notice once again what happens, right? The x minus 2 cancels with the x minus 2. So I'm left with these two things. So I am left with 1 times x plus 2 equals, notice in this scenario, the x plus 2 cancels with the x plus 2. So I'm left with these two terms. I'm left with 3 times x minus 2. And then in this case, the x minus 2 cancels with the x minus 2. The x plus 2 cancels with the x plus 2. Don't forget, I had an x here, right? There was an x there, yes. So I'm left with minus 6x, okay? If we distribute, we have x plus 2 is equal to 3x minus 6 minus 6x. So now here we have like terms. So that leaves me with x plus 2 is equal to minus 3x minus 6. Okay. I always like moving the smaller x first, so I'm going to add 3x on both sides. I'm going to add 3x, and that leaves me with 4x plus 2. This cancels with this, minus 6. And then we subtract 2 on both sides. And if I do this, that will leave me with 4x. The plus 2 and the minus 2 becomes 0, and that is equal to minus 8. And then finally, if I want to find x, I would divide both sides by 4. And if I do this, we have 1x is equal to negative 2. But as I said before, right, make sure, check your answer. Make sure to check your answer. So let's check. Check. Okay, you want to make sure you check. So remember, our original equation is 1 over x minus 2 equal 3 over x plus 2 minus 6x over x squared minus 4. And you will notice that if you put x to be 2 minus 2, okay, you will notice that in this fraction we have 0. Okay, this here is 0, and that's a problem. You can stop immediately. You can stop immediately. So here we're good. 1 over minus 4, this is good, equal to 3 over 0. This is a problem. Okay, that's a problem. We cannot have 0 in the denominator, and this is also a problem. So x equals minus 2 cannot be used as a solution. Okay, so this problem has no solution. This is the answer. There is no solution, period. Okay, no solution. And that's because there is 0 in the denominator. And because, so this tells us that x equals minus 2 is an extraneous solution. Okay? It is an extraneous solution. That's what it tells us. So now let's look at some different types of equation, okay? And we'll look at quadratic equations, quadratics. Now remember, for a quadratic equation, or what a quadratic is, right? Remember, this is an equation that can be written in the general form, which is ax squared plus bx plus c equals 0. And remember, a cannot be 0. So note also that this is called a second degree polynomial. Okay, it is a second degree polynomial. So there are various methods to solve quadratics, right? To solve quadratic, we can use a few methods. So to solve quadratics, we can use a few methods. Okay? One of these methods is called factoring. And this does not work for prime polynomials. Okay? Meaning it doesn't always work. Okay. Then we have what is called a, I don't think this is a method, but I'll try to extracting square roots. Yeah. And the two that are 100% works is completing the square and probably your favorite quadratic formula. Yeah, quadratic formula. Now remember, what is the quadratic formula? Okay, you should know that the quadratic formula is x equal minus b plus or minus the square root of b squared minus 4ac. Everything has to be over 2a. Okay. So these are the methods that we'll go over in this video. Okay. So let's jump right into it. Suppose I ask you to solve 2x squared plus 9x plus 7 is equal to 3. Now this is quadratic. This is a quadratic. Okay. And to solve quadratic, it must be equal to 0. Okay. So this is something must be equal to 0. Okay. You have to remember that it has to be equal to 0. So in our problem, we have 2x squared plus 9x plus 7 equals 3. The first thing we're going to do is minus 3 on both sides. And if we do this, we end up with 2x squared plus 9x plus 4 is equal to 0. And now we will try to factor. Okay. So if we try to factor this, okay, we have 2x squared plus 9x plus 4 is equal to 0. If we try to factor this can be factored. Okay, we will have 2x plus 1 and x plus 4. And now each one of this is a factor. Okay. So we take each factor, 2x plus 1, and we set them equal to 0. And x plus 4 equal to 0. Each factor has to be set equal to 0. And then we solve for x. So we minus 1 in this case. And that will leave me with 2x is equal to negative 1. and then we subtract, we divide both sides by 2. And if we do this, we have x is equal to negative 1/2. Yeah? Remember, you should check the answer. And then we do the same thing. We minus 4 on both sides. And if we do this, we end up with x plus 4 and the minus 4 cancel equal -4. So this here is a possible answer. So after you check each answer, you have to check both of them, okay? We will see that x equals -1/2 and x equals -4 are solutions, okay? They are solutions. So this is something you're gonna see, okay? You will see this. So let's look at another example. Let's solve 4x squared minus 4x squared equals 12. So we're solving for x. Notice again, this is quadratic, right? Because you should observe that this is quadratic. Okay? And it's quadratic because the degree is 2. Okay? This thing here, it's a 2, the exponent. So if we take 4x squared equals 12, and like I said, it has to be equal to 0, so I minus 12 on both sides. Notice they are different terms, so you cannot combine them. So we just write 4x squared minus 12 now equal to 0. And we factor. So the greatest common factor is 4. If you take out 4, we have x squared minus 3. That is equal to 0. Okay? Each one of this is a factor. Okay? Each one of this is a factor. So we set each factor equal to 0. So 4 equal to 0 and x squared minus 3 equal to 0. Okay? So obviously 4 cannot be equal to 0. So this is not possible. But on the other side, if I add 3 to both sides, we end up with x squared is equal to 3. And then we take the square root of both sides. And don't forget, you'll end up with a plus or minus there. So we have now that x is equal to plus or minus square root of 3, which really means that x is equal to square root of 3 and let's spell it out. And x is equal to minus square root of 3. Yeah. So our solutions, x equal to the square root of 3 and x equal to the square root of minus the square root of 3. Okay. Those are my two solutions. Let's write them here so we can see solutions. We have 2. X is equal to the square root of 3 and okay. Or we should say or x is equal to minus the square root of 3. These are the possible solutions that will make this true. Okay. Two solutions. Now, if we try to solve Okay. If we try to solve by completing the square now. So let's solve. Let's try to solve. And let's solve by completing the square. And the example we will look at is x squared plus 2x minus 6 equals 0. Okay? Now, make sure in completing the square, there's a few things, and there are many different ways to solve quadratics by completing the square. Different people teach it differently. So the approach I will use, is based on, I have another video and we'll talk about graphing these functions. And this, if you use the same format, it will help you. Okay. Now, the first thing we're going to do is make sure that a is 1, right? So notice that a here is 1, and I'm getting this from that coefficient there. B is 2, and I'm getting that from there. It's a positive 2. And C is equal to minus 6, and I'm getting that from there. So you have to make sure you know what A, B, and C is. Now, in completing the square, in this method, A must be 1. Okay? If it is not, we must factor first. So in this example, A is 1, and we don't have to worry about that. So we have here, okay, x squared plus 2x minus 6 equals 0. And I have a video where I clearly show that specifically how to solve by quadratics, okay? So if once A is 1, the next thing I'll do is move the C term to the other side. So I will add 6 on both sides. And by doing this, I have x squared plus 2x is now equal to 6. Okay? So we add 6 to each side. Now, the next step is to, take half of b, take or divide, I don't want to say, let's say divide the absolute value of b by 2, okay, and add both sides. So we have x squared plus 2x, and we know that that is equal to 6. But what I'm going to do is add b divided by 2, okay? And we also have to square it. Okay? So divide b by 2, we need to square it. Divide b by 2, okay? Square it. Square it and add to both sides. Okay? So we want to make sure we do that. Okay? So by doing this, okay, we now have x squared plus 2x plus 2 divided by 2 is 1, and I'm not going to write 1. I'll leave it the square there. and that's equal to 6 plus 1, oops, in red, 1 squared. Okay, so that's what we have so far, right? So if we do this, what I'm going to do now is to factor this side here, factor. If I factor this, I will get x plus 1 quantity squared, and that is equal to 6 plus 1 squared is 1. Now, you will see later on what I do here. So basically what I'm doing is like a shortcut. I take the x, and that goes in my parentheses. I bring down that sign, and that 1 also goes there. And the square now goes on the outside of that. That's like a little shortcut that you will see will always work over and over again, right? That will always work over and over again. So if we do this, okay, or if we continue, we have x plus 1 squared is equal to 7, okay? And then we take the square root of both sides. We take the square root of both sides, but don't forget, when you take the square root, you get plus or minus. So this, now we have x plus 1 is equal to plus or minus square root of 7. Okay? And then finally, we minus 1 on both sides. And by doing this, we have x, the plus 1 and the minus 1 cancel, minus 1 plus or minus square root of 7. Yeah? So the solutions are x equals minus 1 plus the square root of 7, or x equal minus 1 minus the square root of 7. So here are your two solutions. Okay. Now you will see that when when a is a value that's not 1, okay, this becomes a little bit more intense, but not that bad. Okay, just a little bit more intense. So just keep that in mind. Okay. So as I said, I'm going to break this up into 2 videos, and I don't want them to be too long, so I will stop here for today, okay, or for now, and there will be a follow-up video on this. As always, please practice as many problems as possible.